Well, we took a peek at a first type of series, namely a telescoping series. How about something a little more common? You recognize this from your studies of pre-calculus. This is the infinite geometric series. We could discuss finite geometric series as well, but I just want to concentrate on infinite geometric series. So, question, will an infinite geometric series always converge? If not, for what values of R will it converge? We'll take a peek at, going back to my definition, the nth term of the sequence of partial sums of a geometric series. Here it is. Actually, here it is again, but I'm missing my exponents. So what I want to do for the second line is I just want to rewrite the first line in such a way that I multiply both sides by R. Now, if you let me use my 9th grade algebra skills and subtract the second equation from the first, I think it's going to give me this. On the right-hand side, cancellation all over the place. Well, at least it's diagonal cancellation. As a matter of fact, I think on the right-hand side of both these equations, everything cancels, except for the first term on the right-hand side of the first equation, and the last term on the right-hand side of the second equation. Now, in factoring out an S of n, isolating S of n. Remember what I'm trying to do. I'm trying to find out for what values of R is the nth term of the sequence of partial sums going to converge or diverge. Now concentrate on the second term. If this R value in absolute values is not strictly less than 1, then the second term is going to increase that bound. However, if it is the case that the R value in absolute values is strictly less than 1, then I think the whole second term, when I take the limit of both sizes and increase that bound, is simply going to go to 0. That being the case, the nth term of the sequence of partial sums is going to go to this value if I'm dealing with an infinite geometric series and if the R value is strictly less than 1. Let me say that more efficiently or more formally. Given a series of this form that is infinite geometric, its sum is just an A over 1 minus R, provided that R in absolute values is strictly less than 1. In particular, here's an infinite geometric series. R is negative 2/3, satisfies that requirement. My A is nothing more than the 5, and so I'm left with this. I can't read my own writing. That should be a 15. So albeit I have an infinite collection of terms, it's just in the end, they add up to exactly that value.